Landboards presents OptoCoupler cards, the OptoSmall and OptoFast cards. Our OptoCoupler cards each feature 4 channels and they come with several configurations. The cards are also small form factor at 49mm by 49mm or a little bit under 2 by 2 inches. Here's the OptoSmall card. On the left side of the card are the inputs and on the right side of the card are the outputs. The input circuit is a unique circuit which includes an NPN transistor to drive the photo LED. This reduces the input current required by the card. Here's the schematic for the OptoSmall card. You can see the drive transistor driving the LED on the input, and it has a conventional resistive pull-up on the output. Here's the OptoFast card. It has some options that it provides that are not in the OptoSmall card. It allows you to bypass the input transistor and not use it, and on the output it has a fast circuit which speeds up the speed of the output. The schematic sheet here shows those options. The input transistor is optional with a bypass around it, and on the output that fast resistor can be installed or not installed. In this way the card has quite a few choices and options for speed. We've created an automated tester for the cards to ensure that when they leave us, they're operating properly. The tester consists of an Arduino clone, the unit under test, and an OLED display card that displays the results. Here's the tester running a loop, literally more than 1,000 times, testing each of the individual channels over and over again. So let's take a look at the sort of performance you get from each kind of card. The OptoFast card can be configured to be identical to the OptoSmall card. This can be done by setting the OptoFast card to use the input transistor and not the fast output. The first setup here shows the worst case timing. That's for the input transistor case and with no accelerated output fast circuit, and the time was about 28.8 microseconds. The output fall time was significantly better at 1.8 microseconds. Here you can see the advantage of enabling the fast output resistor, including that, and the timing went from 28.8 microseconds down to 6.7 microseconds, which is a pretty substantial speed increase. The fast output speed up does come at a cost though, because the fall time and the output increased from 1.8 microseconds to 3.6, but this isn't a very big increase compared to the large gain that was found on the output change, too high. Directly driving the LED instead of going through the input transistor doesn't change the part speed very much, just maybe a few hundred nanoseconds. And that's also true here, even in the fast mode, where you can see it really is only a few hundred nanoseconds difference between the two. And that makes sense because the transistor switching time is fairly quick. So exactly what is the trade-off involved with directly driving the LED or using a transistor to drive the LED? Including a drive transistor reduces the drive level from the circuit that's driving the LED substantially from maybe 10 or 20 milliamps or more down to a microamp level. However, this comes at the cost of reduced noise immunity, as the input voltage over 7/10 or 6/10 of a volt will drive the LED. That's significantly higher than the LED voltage. This difference could be an issue in a highly noisy environment. We hope that the OptoSmall or OptoFast does meet your opto-coupled needs. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of these cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.